Assalamualaikum and good day everyone. So today we will like to present our project titled LCD Parking Monitoring System. So this project focus on designing a smart parking monitoring system using the ATE Mega 64 microcontroller. Alright, so this slide shows the overall circuit for LCD parking monitoring system that use ATE Mega microcontroller. As you can see, there is PD0 and PD1. They are used as the entry and exit sensor. So for port A, display the current occupancy, and port B show the available parking slot using the 7-segment display. The LCD operate in 4-bit mode using port C and port D to display messages such as welcome, thank you, and full. Overall, this circuit allows real-time monitoring and display update. This project was developed by Team 4. So our team members are Amrul Haziq, Nur Alamashita, and myself, Alisa Zahira. Each member contribute to different parts of the project, including circuit design, programming, and system logic. So for introduction, the main goal of this project is to develop an automated parking monitoring system using the ATmega 64 microcontroller, so which can track vehicles entering and exiting a parking lot in real time. The system monitors two key parameters, which are current occupancy and available parking slot, and display this information clearly using the 7-segment displays and an LCD. So this helps driver make faster decision and improve overall parking efficiency. As for the problem statement, most conventional parking lots today are considered blind system. Drivers do not know whether parking spaces are available, which causes them to waste time and fuel searching for parking. So at the same time, parking managers do not have a live count of vehicles inside the parking area, making monitoring difficult. Alright, I'll move on to the project objective. So here we are. There are 3 project objectives. First, to display real-time occupancy and availability using the 7-segment display. And then the second is to provide clear bilingual instruction to drivers using an LCD during entry and exit. And then for the last one is to prevent overcapacity by automatically blocking entry when the parking lot is full. So now I'll pass on the next slide to my friend. Thank you.
Okay, so for our security design for project, we use a 80 mega 64 microcontroller for our central control. This is the brain of our project that process all information. Okay, so we have a input unit which is two button, PD0 and PD1. So for button PD0, simulate a car arriving at the gate, and for PD1, exit button is a simulate a car leaving the parking lot. This button trigger the system to update the car count and change the display message. So for 7-segment display, we have a port A, which is to the left, and right we have a port B. So for 7-segment display for port A, it shows the total occupancy, which is the number of car currently inside. And for port B, it shows the available slot, so driver know how many space are left. So we use a BCD format, so the number are easy for people to read. So for LED row, for top row, we have a show the number of book slot in binary code, and for bottom row, it show the available slot in binary code. This LED give a quick visual for a status for the parking lot. So for LCD, the screen provide a real-time instruction and greeting to the user. It display a welcome or thank you message every time a car enter or exits. Most importantly, it show a full warning if all 50 spots are taken. So for operational logic, the system enter and initialize phase which port A and port B are configured as output to drive the 7 segment display, while the LCD module is initialized in a 4-bit mode using port C and the port D. The system begin operation with a pre- predefined maximum parking capacity of 15 slots. During runtime, the microcontroller continues monitor entry and exit sensor, update the occupancy and availability count, okay, and refresh all display output in real time to reflect the current parking status. So we have a three flowchart. So for a main system flowchart, the system begin by initialize the 80 mega 64 port, the setting port A and B as output for the display and configure the entry or exit button on port D as input which pull up register. The LCD is set up in 4-bit mode and the initialize variable are defined with a total of 50 available slot and 0 occupied slot. After update the 7 segment display to show this starting number in BCD format. The program enter a continuous loop. In this loop, it constantly check the sensor to see if a vehicle is entering at PD0 or exits at PD1. So for next flowchart, we have the entry sequence flowchart, which is trigger when a PD0 trigger. When the entry sensor is triggered, the system first clear the LCD to prepare for a new message. It check if there is any space left. If there is, it decrement the available count and increment the occup count. The LCD then display a message welcome, specialized, like terima kasih and visit us again. The hardware display then update to show the new count. The LCD is clear and the system wait for the sensor to be released before returning to the main monitoring loop. And for the full condition flowchart, this logic act as a safety barrier when the parking lot reach maximum capacity. If the available slot reach zero, the system automatically block any new entry from being count. To inform driver, the LCD display a high priority warning. Maaf, lot penuh and sorry, full. Finally, it forced the display to show 50 on port A when a full occupancy and zero on port B when no availability, so that management and driver have a clear visual confirmation that the lot is full. So for entry sequence, when a PD0 trigger, when vehicle is detected at the entry sensor at PD0, the system first will detect the entry by checking if the available slot variable is greater than zero. If space is available, the software update the counter by decrement the available count and increment the occupancy count to guide the driver. LCD clear and display a dual language welcome message, which is selamat datang on the first line and welcome on the second line. This message stay on the screen for 1 second delay before clearing to prepare for the next vehicle. Finally, the update counts are sent to port A and port B in BCD format to reflect the 7 segment display and LED immediately. So for exit sequence, when her vehicle triggered the exit sensor at PD1, the system first validate the departure by assuring the available count is less than the total capacity of 50 to avoid logic error. uh, Validate the software, update the counter by increment the available slot and decrement the current occupancy. The LCD then provide feedback by displaying first line is terima kasih and second line is visit us again for a 1 second direction. To ensure the accuracy, a loop is implemented which pause the program until the sensor is physically released, preventing a signal car from being count more than once. Okay, so after understanding the operation flow, the next presenter will explain the coding and system result.
Next, I will explain the full condition logic of our system. When the available parking slots reach zero, the system automatically enters a full state. in this condition, any new entry detected at the entry sensor on PD0 is ignored, which prevents the parking count from exceeding the maximum capacity of 50 vehicles. To inform drivers clearly, the LCD displays a warning showing "Maaf, not penuh" on the first line and "Sorry, full" on the second line. At the same time, the 7 segment displays show 50 for full occupancy and 00 for available slots. This logic ensures safe operations, prevent overparking, and maintains accurate parking data. For this slide, it shows the main structure of our program written in C language using AVR GCC compiler. First, all the required header files are included, and the system clock frequency is defined as 1 megahertz. And also, the LCD control pins are defined clearly to match the hardware schematic. We also implement LCD functions such as LCD CMD, LCD data, and LCD print, and LCD init. These functions allow the LCD to operate in 4-bit mode, reducing the number of I/O pins used while still providing reliable display control. This modular coding approach makes the program easier to understand and maintain. This slide shows the main logic inside the while loop. The system continuously monitors the entry sensor at PD0 and the exit sensor at PD1 using polling. When an entry is detected, the program checks whether parking space is available before updating the counters and displaying a welcome message. Similarly, when an exit is detected, the available slot count is increased and a thank you message is displayed. Sensor release loops are used to ensure that each vehicle is counted only once. The software debouncing method helps prevent double counting and improves system accuracy. As for discussion for this mini project, this project successfully solves the problem of traditional blind parking systems by combining 7 segment displays for numerical data, an LCD for user guidance, and a binary LEDs for backup monitoring. The system provides clear and reliable parking information in real time. The use of PCD formatting ensures that all numerical values are accurate and easy to read, while the full condition logic prevents overparking. Although polling is used instead of interrupts, it is suitable for this system size and provides predictable performance. Overall, the system improves the traffic flow, reduces driver confusion, and simplifies parking management. We are now in the conclusion part of the project. In conclusion, the LCD parking monitoring system demonstrates how the Atmega 64 microcontroller can be used to create an efficient, reliable automated parking solution. The system accurately tracks vehicles, entry and exit, displays real-time parking data, and provides clear guidance to users through bilingual LCD messages. With features such as software debouncing and automatic full capacity control, the system maintains high reliability and data accuracy. This project shows that a proper hardware and interfacing combined with structured software design can transform a simple parking lot into a modern and guided facility.